Hi everyone. In today's challenge, we are going to solve this problem. The problem name is predict the winner, and the problem number is 486. Alright, guys. So first of all, what we are going to do? We are going to clearly understand the problem statement. After understanding the problem statement, then only we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? So after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. And guys, if you want to have a look on the solution, which I'm going to write in this video for Python, C++, Java, and JavaScript, I will share the link in the description. You can go through that particular link and you can find the solution which I'm going to write in this video, right? Now, guys, let's see what this problem says, right? So let's understand the problem statement. So, guys, problem says you're given an integer array, nums, and two players are playing a game with this array, player one and player two. So, guys, this is clearly mentioned that we are given one input only, that is nothing but an array, right? And that is also going to have an integer data type, right? So, integer array we are given. Second thing is nothing but they are saying us that we have to play, right? Player one and player two. They are going to play a game with this particular array, right? This makes sense, right? So for now we know this much thing, right? So what we are going to do? We are going to take a simple array first of all. Let's take this example to array. So we are going to take 1, 5, 2, 3, 3, and 7. So guys, this is an array which I took from example 2, and player 1 and player 2. They are going to play a game with this particular array, right? This makes sense, right? Now let's see the rule, right? Let's see the rule of game. So game rule says, so player 1 and player 2 take turns with player 1 starting first. So the first rule is nothing but first rule is player 1, P1 is always going to start first, right? That makes sense. Second is both players start the game with a score of 0. So initially, second is nothing but score of P1 is also 0 and score of P2 is also 0, right? Fine. At each turn, the player take one of the number from either end of the array or from either end of the array, which reduce the size of array by 1, or we can say starting of the array, right? So it says that at each turn, the player take one of the number from either end of the array or starting of the array, right? Which reduce the size of array by 1. So I hope it makes sense. So what it says that simple, if you have this array, right? So what is the starting and ending element? So this is the start of an array. This is the end of an array, right? So either player can, if let's say player one has its turn, so player one can either take 1 or 7. It cannot take in between of these, right? It cannot take 5, it cannot take 233, but it can take 1 or 7. It has choice from starting or the ending element, right? Fine. This is our third rule. Now the player add the chosen number to their score. The game end when there are no more element in the array. So after that, let's say player choose the first element, that is 1. So player gonna add 1 in their score. If player chooses 7, then player gonna add 7 in their score, right? Fine. And after that, once all the elements over, there's no more element left in our array. So then what we are going to do? We are going to check who has a more score, right? Return true if player one can win the game. So how player one can win the game? If the score of both player equal, then player one is still the winner. So the first thing in anyone, if a score of P1 is greater than P2, then it's winner. P1 is winner. Otherwise, if both are equal, then also P1 is a winner, right? Okay, and you should also return true, right? Fine. You may assume both players are playing optimally. So this is the last line, which is going to be more confusing one, right? So both players are playing optimally. What does this mean? This means that no one want to lose a game. So let's play a game between you and me, right? So what I'm going to do, I have this array, right? So what I'm going to do, I'm going to say first P1. Who want to become a P1, right? So let's say first time I'm going to become P1 because I'm always going to win. Here you can see how, right? So I'm P1 and you are P2, right? So what I'm going to do, I'm going to say I'm going to pick any element. I can pick either 1 or 7, right? So this is my choice. I can pick either 1, I can pick either 7. So what I'm going to do, I'm going to pick 1. So I have a score 1 initially, right? Initially was 0, 0. So as soon as I pick 1, so I'm going to say I'm going to add 1 in my score. Fine. P2 initially 0. So now term is for P2. So what P2 is going to do? P2 are they going to take 1 is already going to remove from this array, right? Because I have choose pick already. Now P2 have a choice that they P2 can pick 5 or P2 can pick 7. Suppose these are the starting and ending element, right? So let's say P2 pick 7. Okay, P2 pick 7. Now this has been removed. So I will pick nothing but 2, 3, 3. 2, 3, 4 is going to be total. And then there's only one element left, 5, which is going to pick by P2, right? So P2 will have now 12. So you can see P1 is winner here, right? So P1 is because it has greater than P2. Now let's take another scenario. So what is that scenario? That scenario is nothing but this one, right? So I have chosen a P1 only, right? Now P2 has choice either he can choose 5 or 7, right? So P2 either can choose 5 or 7. So first time P2 had choose 7, so P2 was lose. P2 got lose, right? Now it's not choosing a 7, it's choosing a 5. So let's say P2 choose 5. So still I'm going to choose 2, 3, 3, which is going to be 2, 3, 4, and P2 is going to choose now 7, which is left, so it is going to be 12. So again you can see in both the scenario P2 is losing the game, right? So no matter P2 either choosing a 5 or P2 either choosing a we can 7, P2 always gonna lose it. So why it gonna lose it? So that is nothing but they're playing optimally, right? So that main depend on my first move. So if I started, I choose a first leap 1, right? So that's why P2 always gonna lose. If I choose 7 in starting, so definitely P2 is gonna be. So let's take that scenario as well. So what I'm gonna do, initially both have 0 0, and I can choose either 1 or 7, right? So let's say I choose a 7, right? So I choose a 7, so I will have a 7 in my score, and 7 will gonna remove. Now P2 can choose 1 or 2 3 3. So P2 definitely gonna choose a 2 3 3. Fine, because it is also playing optimally. Now either I can choose 1 or 5. So let's say I choose 5, so I'm gonna get 12, and P2 is gonna have a we can say 2 3 4, right? You can see, if I make a we can say bad move in the first starting position, then I will definitely going to lose the game. But as I am also playing optimally, so I will not choose a we can say 7, I will definitely choose a 1, right? So this is nothing but we have to think about the perspective of the player, right? We don't need to think about ourselves. We have to think about perspective of the player 1 and player 2, both are playing optimally. And how we can do this, we will see in the logic part. But I hope you understood the game, right? Either can choose first element or the last element, and this will keep going until there is no element present in our game. After that, we can check the score. If P1 has a maximum score, then P1 will gonna be winner. If P1 have a equal score than P2, then also P1 will be winner, right? Fine. Now let's see the example one, and let's understand the example one as well. So in example one, we have 152, right? So first one is always going to be for P1. So P1 can choose anyone, 1 or 2. Let's say P1 is choosing a 1 and P2 will choose a 5, right? After 1, P2 will choose 5 and P1 will choose 3. So you can see P2 will win, P1 is losing here. So we are going to turn fast. P1 can't win here, right? Why? Because if I take another scenario as well, so if I take another scenario, so here I'm not choosing 1, I'm choosing a 2, right? So let's say I choose 2. So still P2 is going to choose a 5 and I will going to choose a 3. This next one again, I'm losing a game, right? So you can say P1 is always going to lose a game no matter what move P1 gonna take initially. So P1 is always gonna lose the game, right? I hope it makes sense. So it is gonna be fast. And P2 is always example 2. You can see it's gonna be 2, right? Because we have seen already this example. I'm gonna choose starting first 1. After that, player 2 has to choose either 5 or 7. Any of the we can say element is chosen by the player 2. This will open 2 3 3 for us. So we can pick 2 3 3. So we'll get initially 2 3 4 as the score, and player 2 will have a 12 as the score. So P1 is always going to be in this case, right? So we are going to return true in this case. So we have seen the like a common understanding part, right? So we have seen it with the common understanding part, but how we can implement this one? How we can tell the code that you have to choose the maximum, you have to choose the minimum, you don't need to choose this one, you have to choose the first one, you have to choose the last one. So everything, how we can tell this to the code? Let's see that part, right? So let's move to the logic part and let's see how we can do this one. So whenever we go to the question like this, both are playing optimally, you have to play optimally, you have to think about this. So every time whenever you get a question like game theory based, so don't have to think about both the perspective. You have to think about the only one perspective. Either you can pick a P1, you can pick a P2. You have to try to play optimally either P1 or P2. Just simple these things, right? So why I'm doing, saying this one, let's see that part, right? So I'm going to understand the whole logic. So we are going to pick this example to only, and we are going to understand how we can solve this with the logic part, right? So guys, what I'm going to do, I'm just simply going to use a recursion. I'm going to choose all the moves, right? So recursion, initially I'm at 0. I have this 0 index, 1 index, second index, and third index. So we have initially this particular position for P1. So again, I'm saying this is for P1 because P1 will always going to start a first. Fine. P1 can either choose 0 or a P1 can either choose 3 index, right? In this index element. So let's say P1 had choose a 0, right? So then 10 will be nothing but for P2, or P1 choose a 3, then also 10 will be P2. You're getting this part, right? So here if P1 had choose 0, so what we are going to left with? So we are going to move to the one index ahead. That is nothing but 1, and this end will be the same. If P1 choose a third one index, so we are going to decrease one index, so it's going to be 0, 2. It makes sense, right? Now P2 is also going to play optimally one. P2 is also going to play optimally. I hope you're getting this. So P2 also can choose the last or the we can say front first element, right? So here if it choose the last element, so let me take a little above, or front element. So what I'm going to do, I'm going to say if it choose the last element, so you are going to say P1 turn, and here you're going to say it's going to be P1 going to have 2 and this going to be 3. If it choose the last element, so P1 P2 P1 is going to be 1 comma 2, right? So this is going to be the numbers. And here as well, if P2 choose the first element, so P1 is going to have now 1 to 2. If P1 choose the last number, so P1 is going to have now 1 we can say 0 comma 1, right? So this is the simple scenario. You are getting the recursion part. Now how this is going to helpful for us, let's see that part. So guys, initially P1 have a 0, right? Nothing in the score. So if P1 chooses 0, so what we are going to do, we are going to add a 1 into P1. So we are going to add 1 into P1. If P1 choose the last element, we are going to add a 7, right? So this makes sense. So I'm going to change the color. So this is nothing but this is how it look like. So then we are not gonna say for P2 just do that part, do that part. No, we are not gonna call for P2. We are gonna use the game theory. We are not gonna call for this P2. We are gonna say fine. Now you can remove this part. You can directly call this one. You are getting this part right. So if I take a zero element, first element, then I'm gonna call for this one. If I take a last element, remove for P2, I'm not gonna consider P2 here. I'm gonna say call this one. So you're getting this part. I hope you're getting this much, right? So what I'm doing here, that we have first of all seen how the game is going to work, but then we have removed the occurrence of P2. Now we have P1, P1. If P1 take a first element, so next choice will be for P1 is going to be either take second index or third index, either take first index or second index. You have to take a, here, it's going to take a playing optimally part, right? So we have to do nothing but this much, and we have to take this part as a minimum one, right? Why I'm doing this, I have to take a minimum. Just also if you get it, just let me know in the comment. So we have to take a minimum, otherwise I will let you in that later, but we have to take a minimum here. I will tell you after once this recursion complete. So once we have P1, P2, this thing part, then what we are going to do, we are going to say again you can take any more index, you can move to that one, any other index, any other index, any other index, any other index, right? So we are going to stop only when this I is greater than j, right? When 1 is less than 2 is keep going, right? But next point it will be always be greater than j. So 2 is greater than 1, like this is going to happen. So we have to remove that. Well, we have to break from there, right? We have to return 0 from there. Now let's see why we are going to return minimum here. So as you know guys, this is in between we have P2 turn, right? So P2 will always going to take a maximum one. P2 also playing optimally one, right? So P2 is going to take maximum from this, then we are going to return to the P1, right? So we have removed this part, right? I hope you're getting again if you forgot. So we have P2 where it was saying like this, then we are calling this one, right? So what I have done, I have removed this P2, but remember this P2 is gonna always take a maximum one. It also playing optimally. So if it is giving a minimum one, so if it is giving let's say 4 and it's giving a 5, right? So what it gonna do, it's gonna take a maximum. P2 also gonna take a maximum, but here we have to return a minimum of this. Why? Because minimum of P1 and P2, this P1 and this P1, we have to return the minimum because P2 is gonna also play optimally. So we have this P2 will always left us with a minimum number. Right. If we take a maximum, that means P2 is not playing optimally. It's allowing us to take a maximum number. Right. So P2 always take a maximum, want to take a maximum in their score. So it will also pick only pick that particular part which give a minimum to the P1, minimum to the P1, right? So that's why I'm saying that we have to take minimum from this or this. Then if we take a minimum, that means P2 has picked the maximum one from this particular position. That means P2 has played optimally. If we take a maximum, that means P2 has not played optimally. It allow P1 to take a minimum or to take the maximum score, right? But P2 also win, so it will play optimally. So P2 will play optimally, so P2 will take a maximum score. So P2 take a maximum score, so P1 will left with a minimum score. So we have to take a minimum from this. If we are getting 100, if we're getting a 50, so P2 will pick 50. So we have to give 50 to the P1. I hope you're getting this part, right? So this was the simple basic logic. So now let's move to the implementation part and let's see how we can implement this one, right? Simple logic, we are going to use this recursion. And here we are not going to even memorize it, but you can memorize it to get a maximum, right? See, we can say runtime, right? So here you can see num's length is 20, means we are going to have max array of size 20. So we don't need to memorize it, but if you memorize it, you will get a better result, right? I'm again saying you can memorize it to get a better result, right? Now let's move to the implementation part. Here I'm first of all with the Python. So what I'm going to do, I'm going to say fine. So what first of all we can do, we can make a function solve where we have I and j, this recursion, and we're going to see if I is greater than j, then you have to return 0. Otherwise, what you're going to do, you're going to either pick first or second, last, right? So either you can pick 0, either you can pick a 3, right? 3 index. So what I'm going to do, I'm going to say you have to pick a first one. So if you're picking a first one, you're going to add nums of 5, and after that, what you're going to like, you're going to minimum solve both. You're going to take minimum from, say you have picked the first one, right? So you can take minimum of 2,3 or 1,2, right? So this is going to tell us why. So we have taken first element, right? So I plus 1 definitely going to be happen. Now depend on the second P2. So P2 either can take a last element. So if we're going to take a last element, so we are going to do j minus 1, fine. And either P2 can take a first element only I plus 2 comma j, right? If you're getting this part, so same thing guys over here, simple thing. So what I'm doing here, I have take a first element. So if simple, I have tell you here, so I have take a first element, right? So I have take a first element, so this is nothing but this is the space for P2 now. So this is the space for P2, right? Now P2 also gonna take any move, right? So let's say P2 took a first move only, so I plus 2 comma j, or P2 took a P2 took a, we can say last move, so I plus 1 comma j minus 1, right? So this can be the possible move for P1 after taking a P2 move, right? I hope it makes sense, right? So once this is done, Fine. So we have to pick the first element. Same we are going to do for the last. So let's say I'm picking the last element. So last is going to be nothing but nums of j. So then I have to do nothing but I have to solve. I have to choose the last one, right? So I have to remove j minus 1. And now p1, I can choose the first element or second element or last element. So let's say p1, p2 choose the last element, so j minus 2, or p2 choose the first element, I plus 1, j minus 1. Fine. And here, once this is done, then what we are going to do? We are going to say fine. After that, we have to take a maximum from this. So return maximum of first comma last. Right, I hope it makes sense. So once this is done, then what we are going to do, we are going to say call this function for 0 and length of nums minus 1. So this is nothing but the score of p1, which we got now, p1 score. Right, once we got a p1 score, then what we are going to do, we are going to calculate the p2 score. Then we are going to calculate whether which is the maximum, which is the minimum. But p2 score is nothing but we can say total minus p1 score, right? So that will be the p2 score. So total is nothing but we can say sum of nums. Sum of nums is nothing but we can say this is the total minus p1 score is nothing but going to be p2 score. And if p1 score is greater than p2 score or equal to, then also we have to say p1 is the winner. So return 2. So this is the simple thing which we are going to do. Let's run this function, see whether it's working fine or not. And I hope guys it should work, right? So it's taking a time. You can see both the task is pass related, submit this code, right? But you will see the we can say runtime. Here we are not memoizing it, right? So it will always give a bad runtime, right? But it will definitely gonna pass it. So let's see the runtime here. So you can see runtime is 4933 milliseconds. But if I use it memoization here, just one line of changes I'm doing here. LLU cache, which is a regulator. Let's try to submit now. See guys, earlier was 4900, means around 5000, right? Now you can see only 28 milliseconds. It's a miracle, right? Again, I'm saying guys, if you want to memorize it, you can memorize it, right? It will pass the test case for now, but in an interview, you have to memorize it to get a better result, right? Fine, now let's move to the C++. I'm not going to memorize it for next programming language, but I have showed you, right, how it is important to memorize it, right? Directly from 5000 to 28 milliseconds. Fine. Now guys, let's see C++, how what we are going to do. First of all, we are going to calculate the length. So don't need to calculate the length, just calculate the first of all total. Total is going to be nothing but accumulate. We can say nums.begin, let begin, and we can say nums.end, and we can say 0. This is going to be give a total. After getting a total, then what we are going to do, we are going to say fine, let's calculate the p1 score. So in p1 score is going to be calculated by our one function sol, which is I'm going to pass I and j. I going to be 0, j is going to be last element index, which is going to be nums.size minus 1. Then we are going to pass our nums array as well, not array, it's vector. After that, we are going to say if p1 score is greater than p2 score. P2 score is total minus p1 score, right? It is a p2 score. So then you have to return true. So we can directly return this statement. Simple, right? Isn't it? So now let's define one function. The function name is going to be nothing but int sol, int I, int j, and we can say vector, int, we can say nums. And here we are going to say fine. So first of all, check if I is greater than j or not. If it is greater than j, directly return 0. Otherwise, you are going to say int first. You are going to take a first element. So if you are taking a first element, you have to say nums of I plus minimum of, you're going to call this function sol I plus 1. You have to go first element and j minus 1, because let's say the second p2 has choose the last element. But if p2 also choosing a first element, so you have to say I plus 2. J will remain same. In second, nums of j plus minimum of sol. So here we are going to say you are choosing a j element, means last element, so you have to say j minus 1. And let's say the second person, which is the p2, also choosing a j, so j minus 2. And sol, we can say okay, we are doing some mistake here as well, so we will see later. So first of all, this time p2 choose a first element, so j minus 1, like this. So we are not passing here nums, right? So we have to pass in nums as well. So we can say like this, nums, and here as well, and last thing here as well, right? Fine. So once this is done, then what we are going to do, we are going to say fine, now you got first and last, so you are going to take a maximum, return maximum of first comma second. Why I choose a second, I don't know, right? Now let's see whether this is working fine or not. So I haven't memorized it again. I'm saying here you can memorize it by making a map, another map, or by making a vector or 2D array, right? Now let's see whether it's getting passed or not, submitted or not. So it's taking a time, but you can see it successfully got submitted. You're getting a runtime 137. You can get even better by memorizing it, right? Now let's move to the, we can say Java. Or here, what we are going to do, we are going to say fine. First of all, get total. Total is 0. We are going to say for int value of nums. Total place equal to value. Then we are going to say p1 score, which is going to be nothing but sol 0 nums total length minus 1, and we are going to pass this sums array as well. After that, we will return p1 score should be greater than or equal to total minus p1 score, right? That is nothing but p2 score. So it should be greater than previous score. So okay, now let's define one function that is nothing but sol function. So we are going to say that data type is going to be nothing but int sol, and here we're going to say I, int j, int nums, and here we're going to say okay, if our I is greater than j, so return directly 0. Fine. And if it is not the case, so you have to calculate, take either first or last, right? So if you're taking a first, then what you're going to do, you're going to say okay, I'm taking nums of I, and here what I'm going to do, I'm going to say nums of I, not num, and I'm going to say take a minimum, math minimum from weight minimum, so minimum of sol I. I have took a first element, so I have to increment by 1, and this is j. So let's say the second p2 also choose p2 choose the last element, so j minus 1. Fine. And sol, and we have to pass nums as well, right? And sol, and here I plus 1, and j. Let's say this time j2 p2 choose the first element only I, so it's going to be I plus 2. Fine. And in last, which is nothing but nums of j plus math dot min sol I plus 1. If I choose the last element, so I'm going to say I comma j minus 1 nums. But now let's see the p2, what p2 can choose. P2 can choose the first element or last element, so let's say p2 choose the last element, so j minus 2. Fine. And if sol I plus I and j minus 1 was there initially, now here let's say p2 choose a first element, so I plus 1. Fine. And after that what we can say, fine, so we can say it is the case, now return the maximum of math dot maximum, right? Math dot maximum first comma last. Right. Now what we are going to do, we are going to say let's run this function, see whether it's working fine for sample test case or not. And you can see we got an error just because so we haven't passed a nums here. Fine. And let's see now. And you can see guys, both the test case passed. Let me to submit this code as well. And again here I haven't not more memoized it, but you can memorize it, right? So you will get a better runtime. Now let's move to the JavaScript. So first of all, we are going to get total, which is 0 for const value of this, we can say nums, we can say total plus equal to value, and after that we can say p1 score, which is nothing but we can say, let me write score, nothing what I'm saying, p1 score is nothing but initially a function sol 0 nums dot length minus 1, and we are not going to pass anything else here because we are going to make a nested function. And then we are going to say return p1 score should be greater than or equal to our p2 score, and p2 score is nothing but total minus p1 score, right? It is going to be p2 score. Fine. So we can say return this much. Now let's define this function, sol function. So I'm going to say okay, sol function is nothing but const sol, and it's going to take only I and j parameter. Fine. And here we can say fine. So what we are going to do, we are going to say if our I is greater than j, so return 0. But if it is not the case, so choose either first element or second element. Both take the maximum from first or last, right? So we can say let first is going to be nothing but sol. First of all, take a nums of I, take a first element plus sol, and here what you're going to pass, you're going to pass I, and I plus 1 you took a first element j. Now let's say the p2 is going to choose the last element only, so j1, or we can say sol I plus 1 I plus 2 comma j. Let's say p2 also choosing a first element only. So this is nothing but we have to take math dot maximum. Fine. And after that what we are going to do, so here we're going to say let second, not second, we can say last nums of j plus math dot we can say maximum, not maximum, we have to use minimum, right? So p2 is playing optimally. Fine, minimum. And sol we're going to say I comma j minus 1. This is for initially. Now p2 can choose a I or j as well, right? So let's say p2 choosing a j, so j minus 2, or p2 is choosing I, so I plus 1 comma j minus 1. Fine, this is the case. Now what we are going to do, we are going to say we can say fine, we are going to return the maximum, right? Not we can say return maximum of math dot maximum first comma last, right? Now let's see whether it's working fine or not. So I hope guys it should work, right? So you can see both the test case passed. So let's try to submit this code as well. And believe me guys, it will also gonna submit. Let's see. You can see guys, it successfully got submitted. So we have done the implementation with Python, C++, Java, and JavaScript. I hope you understood the logic part, implementation part, and the problem understanding part as well. So guys, if you have any kind of doubt in the problem understanding part, logic part, and in the implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.